Keith McGuinness here with another short video on using PAST. Again, I'm going to work with this set of samples where there's samples taken just to the south of these two platforms and control samples to the east and west. So I've copied and pasted the data into PAST, and note that I've coloured the rows here with reddish colours and bluish colours. Reddish for the impact and bluish for the control, and I've used lighter colours for the two shallower sets of samples and deeper or darker colours for the deeper sets. Now what I'm going to look at here is using PCA, Principal Components Analysis, and in general that should be done on transform data or data which has been normalized. So I've gone to the transform evaluate expression. I'm going to go x minus mean. I find it easier to type than to point and click in here, and compute and close. And I selected the variables I wanted to transform before starting, and it's now transformed all of those. So PCA, multivariate menu, principal components, and we get this little panel up here. Now, what is happening here is the first principal component, or the first axis, which will be the x-axis, is accounting for a large proportion of the variation, about 65%, and the next axis is accounting for about another 25%. So the first two axes explain 90% or so of the variation in the data. This means a 2D graph will be a good representation. Alternative way to look at that is with the scree plot here, which just shows the same values in graphical format. And you can see the first one is 65%, another 25%, so much of the variation is explained by those two axes, and the third and fourth axes account for relatively little. Now, the main result here is the scatter plot, so let's get that up. And what I've done is turned on a few options here: row labels, convex hulls, and the biplot. And I'm going to modify this just a little bit more by right-clicking on the graph. I'll bring up this panel, I'll make the symbols bigger, and I'm going to switch to point symbols and thick lines. And I think using the points instead of the symbols, square, triangle, and so on, makes the graph more appealing. You may think otherwise. The convex hulls simply creates a shape that contains all of the points, and there's only 3 samples here, so essentially it draws triangles. And what you can see is we've got the shallow samples to the right or east part of the map, the deep samples over here on the other side, hydrocarbon impacted samples are at the top, and the control samples are down the bottom. And the vectors on here, or the lines, indicate the direction in which variables are changing. So hydrocarbon is increasing as we go up this way, nutrients that way, and depth and sediment that way. You need to pay attention when you're interpreting the change in depth to whether depth is negative or positive. In the new simulation, depths are negative because they're below sea level, and that will affect the way in which this line goes. Otherwise, I think this graph is relatively self-explanatory. Another option here is to look at the loadings. So let's bring this panel up and have a look at it. And now what it's showing here is, first of all, for axis 1. And if we look at axis 1, it is mostly to do with depth and sediment, with nutrients going in the other direction. And hydrocarbons doesn't figure very strongly on this particular axis. So the magnitude of the bar here, or the number, tells you the importance of that particular component. Switch to axis 2, which is the y-axis, and you can see that this is dominated by hydrocarbons. The other variables have little influence on this particular axis. So we go back up here. Changes in this direction in the environmental variables are mainly reflecting increases in hydrocarbon as we go this way. Changes this way are reflecting changes in depth.